Hello class, welcome back to Statistics and Mathematics YouTube channel. Today we'll be treating a topic called hypergeometric distribution. This is the fourth discrete probability distribution video that we are doing, right? So at the end of the day, we learned something on binomial distributions. We are going to tap that idea from binomial distribution in order to understand hypergeometric distribution. So if you haven't watched that video, kindly go and watch, get yourself satisfied with that video, and then come to the hypergeometric video, so that you really get the concept very well, right? So the hypergeometric distribution, right? We are saying that, for instance, when the sample is done without replacement, the binomial distribution does not give exact probability since the trials are not independent, right? So for hypergeometric distributions, when the trials are selected without replacement, right, we use hypergeometric distribution to do. So when we are treating the binomial distributions, we saw that the trials are independent of each other, right? But here the trials are not independent of each other. So if the trials are not independent of each other, it will be very difficult for us to use the binomial distribution to do that, right? So the examples that you see here is just giving us a building stone for us to really appreciate the hypergeometric distribution, right? So the result of the problem can generalize by using a special probability distribution called hypergeometric distribution. The hypergeometric distribution is a distribution of variables that has two outcomes when the sample is done without replacement, right? So as we saw in the binomial distribution, the binomial distribution is also having two outcomes, right? But it's always done with replacement. But for the hypergeometric, always it's not done with replacement. So any experiment that is given to you and the experiment is performed without replacement, then you have to think about hypergeometric distributions, right? So before we can solve any hypergeometric distribution question, we have to be able to understand the PMF of the hypergeometric distribution question. And what we can see here is the PMF for the hypergeometric distribution hypergeometric distribution. So before we can really use this PDF, you have to also understand the parameters, the A, the X, the B, the N minus X, the A plus B, and the N, right? So for instance, a given population with only two types of objects, right? So for instance, we have female and males, defective and non-defective, success and failure, right? So right now we'll be using the male and female to make make it very simple for you guys to really understand, right? So for instance, the A here will be the items of the items from A, right? So here we are using the A to represent the females, right? So it will be the item from the females, and the B will be the item from the males, right? And then the A plus B will be the population, right? When we add when we add the female and the males, right, it will be the total population. And the X here will be the event, right, from A. The event that is happening from A, that's the event that is happening from the female. And then the N minus X will be the event that is happening from the male, right? And then the N that you can see is the sample size, right? So when you come here, all the parameters is now explained. The A is the item from the female. The X is the event from A. B is the item from B. The N minus X is the item from B, right? A plus B the total population, and N is the sample size, right? So this is the PMF for a hypergeometric distribution. And then let's come and then apply that to solve a certain question, right? So question 1 said 10 people apply for job as assistant manager of a restaurant. 5 have completed college and 5 have not. If the manager selected 3 applicants at random, find the probability that all 3 are college graduates, right? Find the probability that all 3 are college graduates. So you could see that 10 people only apply for the job as assistant manager of that restaurant, right? Out of the 10, 5 have completed college and 5 have not, right? So here our B, as you can see here, our A will be 5 and our B will be 5. If you want the total population, that's the N plus A, you are surely going to get our 10. So here the A plus B is equal to the 10 that you can see here, right? And then let's continue. He said if the manager selected 3 applicants at random, so here our N will be those who are selected at random, right? That will be for our N, right? It's telling us to find the probability that all are college graduate, right? So our x2 is given as what? Our x2 is given as what? 3, right? So at the end of the day, you could see that the slides has explained it simple for us, right? So here will be, A will be equal to 5, which is for the graduate people. The B is equal to 5, which is for the non-graduate people, because we are having them here, right? We are having them here. And then we have our n. Our n is here, right? The sample applicant being selected was 3. And then our x was given as what? 3 here, right? So if we really want our n minus x, is just picking our n. Our n was given inside the question to be 3, minus our x was also given to be 3, which is going to give us 0, as you can see here, right? So what is left of us doing is to just write our PMF and then just substitute in the distance. So we know that our PMF, right? PMF is given as A, right? Combination X, and then we also have our B combination, right? N minus X times, sorry, here is times, and then divided by what? A plus what? B combination what? N, right? As you can see there, nicely, as you can see there, right? So at the end of the day, this is our PMF. So we are just going to substitute what we have here, right? We are just going to we are just going to substitute what we have here into the PMF. That's what they have done, right? So our A was 5 combination what? Our X, which is 3, right? Times 5 combination was 0. So here was B, and then the 0 place was n minus x, which was given as 0. So 5 combination 0 divided by the total, that's 10, right? 10 combination what? 3, right? So we have 10 combination what? N, and our n2 was given as what? 3. So once you point this on the calculator, you're going to get 10 divided by 120. This 0 will cancel this 0, so we get 1 over 12, right? So this can also be further simplified. So when you point it into the calculator, you can either get decimals, right? So our next question is here. You can pause the video and then solve. After that, you can come and check if your answer is what? Correct. So he said a recent study found that 2 out of every 10 houses in a neighborhood have no what? Insurance. 2 out of what? Every 10 houses in the neighborhood has no what? Insurance. If 5 houses are selected from what? The 10 houses, find the probability that exactly 1 will be uninsured, right? So here we have been given a study to find out 2 out of to find something in, let's say, a neighborhood, right? So here what we can see here is that, you see, we have told us that 2 out of what? 10, right? 2 out of every 10 houses in what? A neighborhood has no what? Insurance, right? So here our A will be given as what? 2, since there are 2 out of 10 people in the neighborhood having no insurance, right? So if you want to find our B, right, our B will be, so right now when 2 is selected out of the 10, we will be left with what? 8 houses, right? So here our B will be given as what? 8, right? Our B will be given as 8. Then if you want to find our total population, that's A plus what? B will be given as what? 10, right? Yes. And then we are left with what? Our N, right? So our small n will be given as what? 5, since if 5 houses are selected from what? The 10 houses. So these 5 houses are selected at random from what? The 10 houses. So here our n is equal to what? 5, right? And then what again? We have to find our n minus what? Our x. And right now we have our n, which is 5, right? And then our x is here. He said find the probability that exactly 1 will be what? Uninsured. So the 1 here is what? Our x, right? Always you get the question, the x from what? The question, right? From here going to this place is what? A preamble that will let you determine that this is what? This is multinomial distribution, this is binomial, this is hypergeometric. But in fact, this question is for hypergeometric, right? So the preamble will help you to detect that, right? So always your x's will be found inside the question, right? Find the probability that exactly 1 will be what? Uninsured. So here will be our x is what? 1. So if you want to get our n minus x, here will be 5 minus 1 is equal to what? 4, right? As this is our preamble, right? As you can see here, this is what our preamble, as you can see here. So once you come here, it's the same thing. X is equal to 2, b is equal to 8, n is equal to 5, x is equal to 1, and then our n minus 1, x is equal to 4, right? So just write down just your PMF, right? Just write your PMF as a combination what x, and then times b combination n minus x divided by a plus b combination what n, right? So this is our PMF. Just substitute this one inside, right? You are just going to, this is our PMF, so you are just going to substitute this one, this one inside the PMF to get this one. Once you substitute inside, there will be 2 combination 1 times 8 combination 4, right, divided by 10 combination 5. And when you point these things on calculator, you're going to get 2 times 70 divided by 252, right? So this one will give us 140 divided by 252, and then 5 over 9 will give us our final answer for the question that we had above, right? So this is our third question, and then this one I would like you guys to just pause the video and then try your hands on it. After you are done, you can continue the video to check if your answers are correct, right? The question says a lot of 12 compressor tanks is checked to see whether there are any defective tanks. 3 tanks are checked for leaks. If one or more of the 3 is defective, the lot is rejected. Find the probability that the lot will be rejected if there are actually 3 defective tanks in the lot, right? Always I've told you that your x will be given in the question, the question, right? So this one from here, coming from here, right, from here to here is just a preamble for you to know which distribution you are talking about, and then to get your preambles down, right? Your parameters down, and from here is what the question. So always your x will be given inside the question. So here you can see that we have been asked to find the value that the lot will be rejected if there is actually 3 defective tanks. So here our x will be given as what? 3, right? Our x is surely going to be given as careful.